Next acidic comparison will be this. This is phenol. This is meta-methoxyphenol. This is methoxy group present on meta position. Meta-methoxyphenol. And this is meta-aminophenol. Amino group it is present on meta position of phenol. So meta-aminophenol. Let's compare their acidic nature. Same technique. Make anions of the molecules. This is the anion of meta-methoxyphenol, which are generated after loss of H positive. Lone pairs are available on oxygen and on nitrogen. That's good. So we will compare their stabilities. The very first factor which is making them stable, first of all, which is unstable? Oxygen is unstable here because it is carrying a negative charge. Which factor make it stable? Means can reduce the negative charge. First factor is this, plus R of O. Stability factor S, which is available in meta-methoxy case also, plus R of O. Stability factor, which is also available here, plus R of O. Stability factor. So only this factor can't decide the stability order. Second, no substituent here, so no other factor. Here, oxygen is present. Oxygen is present in meta position. It can show resonance, no doubt. It will donate lone pair because it have a lone pair and it is attached to benzene ring, so it can show this effect, plus R effect, like this. But because it is present on meta position, if it will show resonance, electrons will not come on this position, which can increase the negative charge. Means, already I have discussed with you, plus R of substituent will affect the stability of oxygen only from ortho and para positions, not from meta position. Check by yourself or check previous videos. When you will draw resonance, when you will move electrons like this, these electrons will not come on this carbon. If the electrons are not coming on this carbon, no harm will be done to this oxygen. So I will say there is no plus R effect from meta position. Nitro group can also show plus R effect because it is carrying a lone pair and it is directly attached to benzene ring. So this resonance it can show. But again, it is also present on meta position. And you know, if substituent is present on meta position, electrons will never come here. And if electrons are not coming here, this oxygen will not get any effect. So I am not considering these effects here. Third, oxygen is more electronegative than carbon, so it will attract electrons due to minus I effect. So here we have minus I of O. Now minus I of O will reduce the negative charge of oxygen because as electrons will transfer like this, so definitely the negative charge of this oxygen somewhere will decrease. Decrease in negative charge will stabilize it. So minus I of O will stabilize it. So it's a stabilizing factor. Same here, nitrogen is more electronegative than carbon, so it will attract electrons. In turns, this carbon will attract electrons from this carbon and this effect will continue, due to which the negative charge of this oxygen will decrease. Means minus I effect of nitrogen is stabilizing this oxygen. That's it. All the factors are written. Now it's a time to conclude. Okay, this factor is stabilizing all the anions equally. Okay. Here also we have stabilizing factor. Here also we have stabilizing factor. But you know, oxygen is more electronegative as compared to nitrogen. Oxygen electronegativity is 3.5 on a Pauling scale. And nitrogen's electronegativity is 3. So which will show more minus I effect? Minus I effect depends on electronegativity. Higher electronegativity, higher minus I effect. So here the minus I effect will be strong due to higher electronegativity of oxygen, and here the minus I effect will be weak as compared to this, because comparison is going on. So minus I of nitrogen is weak as compared to oxygen. So weak. That's it. Means this anion is getting more stability because it is stabilized by strong minus I effect. And here it is getting weak stability or less stability. Because it is getting stability due to weak minus I effect of nitrogen as compared to this one. So this anion is stabilized only by one factor. It will be least stable. It is 1, it is 2, and it is 3. So I am writing order here, stability order. Stability order, increasing order of stability. So which will be least stable? 1, because it is getting stability only by one factor. Okay. Now both are getting stability due to two factors, you can check. But it is more stable because here second factor is stronger as compared to second factor of this case. Minus I effect. Means third is more stable than 1 and second is most stable anion. That's it. After getting stability order, we can easily write their acidic order. The acidic order will be same. Normal phenol will be least acidic. Meta-aminophenol will be more acidic than normal phenol. And meta-methoxyphenol will be most acidic as compared to other two. Reasons? Because anion produced after loss of H positive, this molecule knows that after loss of H positive, I will get stablest anion. Why it is stablest? Because it is getting stability due to plus R as well as strong minus I of O. That's why it is most stable anion. So this molecules know that after loss of H positive, I will get stablest anion. So it will ready to lose H positive as compared to other. If it is releasing H positive easily, so it will become most acidic. Sorry, 2 here. It will become most acidic, followed by meta-amino. Then least acidic will be normal phenol. That's it. This is the second comparison of today's. Thank you very much for watching the video.